Congratulations, you have made it to part 4 of Documenting APIs, a guide for technical writers. This is the video walkthrough series. Alright, and now we can start with what is a REST API. This course is all about learning by doing, but while doing various activities, I'll periodically pause and dive into some more abstract concepts to fill in more detail. This topic is one of those deep dive moments into concepts. Here we'll explore what a REST API is, comparing it to other types of APIs like SOAP. REST APIs have common characteristics but no definitive protocols like its SOAP predecessor. What is an API? In general, an API, or Application Programming Interface, provides an interface between two systems. It is like a cog that allows two systems to interact with each other. In this case, the two systems are computers that interact programmatically through the API. APIs are often pulling and pushing data underneath user interfaces. Jim Basso, an experienced API technical writer in the Silicon Valley area, describes APIs by using the analogy of your computer's calculator. When you press buttons, functions underneath are interacting with other components to get information. Once the information is returned, the calculator presents the data back to the GUI, the graphical user interface. APIs often work in similar ways. When you pushing a button on an interface, functions underneath, when you push a button in an interface, functions underneath get triggered to go and retrieve information. But instead of retrieving information from within the same system, web APIs call remote services on the web to get their information. Ultimately, developers use API calls behind the scenes to pull information into their apps. A button on a GUI, graphical user interface, may be internally wired to make calls to an external service. For example, the embedded Twitter or Facebook buttons that interact with social networks, or embedded YouTube videos that pull a video in from YouTube, are powered by web APIs underneath. APIs that use HTTP protocol are web services. A web service is a web-based application that provides resources in a format consumed by other computers. Web services include various types of APIs, including both REST and SOAP APIs. Web services are basically request and response interactions between clients and servers. A computer requests a resource, and the web service responds to that request. All APIs that use HTTP protocol as the transport format for requests and responses are considered web services. With web services, the client making the request for the resource and the API server providing the response can use any programming language or platform. It doesn't matter because the message request and response are made through a common HTTP web protocol. The web protocol is a part of the beauty of web services. They are language agnostic and therefore interoperable across different platforms and systems. When documenting a REST API, it doesn't matter whether engineers build the API with Java, Ruby, Python, or some other language. The requests are made over HTTP, and the responses are returned through HTTP. The following diagram shows the general model of a REST API. The diagram reads REST API model, and you see requests and responses going back and forth between REST API in Java and an application using Ruby. And in the request, you see the URL using a get method, limiting a response to 5. And then on the response side, you see JSON being used, and it says home 123, location AZ for Arizona, price $200K, home 456, location CA, price $800K. So that model is good to look at. As you can see, there's a request and a response between a client to the API server. The client and server can be based in any language, but HTTP is the protocol used to transport the message. This request and response pattern is fundamentally how REST APIs work. Each programming language that makes the request will have a different way of submitting a web request and parsing the response in its language. These language-specific functions for making requests and parsing responses aren't part of the REST API, though they might be provided in an accompanying SDK. SDK stands for Software Developer Kit. The REST API is language agnostic and handles incoming and outgoing information across HTTP, just like the web. SOAP APIs are the predecessor to the REST APIs. Before REST became the most popular web service, SOAP, Simple Object Access Protocol, was much more common. To understand REST a little better, it helps to have some context with SOAP. This way you can see what makes REST different. SOAP is a standardized protocol that requires XML as the message format for requests and responses. As a standardized protocol, the message format is usually defined through something called a WSDL, Web Services Description Language file. The WSDL file defines the allowed elements and attributes in the message exchanges. The WSDL file is machine readable and used by servers interacting with each other to facilitate the communication. SOAP messages are enclosed in an envelope that returns a header and a body using a specific XML schema and namespace. For example of a SOAP request and response format, see SOAP vs. REST 101. Understand the differences. The main problem with SOAP is that the XML message format is too verbose and heavy. It is particularly problematic with mobile scenarios where the file size and bandwidth are critical. The verbose message format slows processing times, which makes SOAP interactions lethargic. SOAP is still used in enterprise application scenarios, especially with financial institutions, with server-to-server communication. But in the past 5 years, SOAP has been replaced by REST, mostly, especially for APIs on the open web. REST is a style, not a standard. Like SOAP, REST, representational state transfer, uses HTTP as the transport protocol for the message requests and responses. However, unlike SOAP, REST is an architectural style, not a standard protocol. This is why REST APIs are sometimes called RESTful APIs. REST is a general style that the API follows. A RESTful API may not follow all of the official characteristics of REST as outlined by Dr. Roy Fielding, who first described the model. Hence, these APIs are RESTful or REST-like. Some developers insist on using the term RESTful when the API doesn't fulfill all the characteristics of REST, but most people just refer to them as REST APIs regardless. As an architectural style, you aren't limited to XML as the message format. REST APIs can use any message format the API developers want to use, including XML, JSON, Atom, RSS, CSV, HTML, and more. Despite the variety of message format options, most REST APIs use JSON, JavaScript Object Notation, as the default message format. They use JSON because it provides a lightweight, simple, and more flexible message format that increases the speed of communication. The lightweight nature of JSON also allows for mobile processing scenarios and is easy to parse on the web using JavaScript. In contrast with XML, XSLT is more for presenting, or rather transforming, the T in XSLT, the content stored in an XML language. XSLT enables the human readability rather than the processing data stored on a XML format. REST focuses on resources accessed through URLs. Another unique aspect of REST is that REST APIs focus on resources, that is, things, rather than actions, and ways to access the resources. Resources are typically different types of information. You access the resources through URLs, uniform resource locators, just like going to a URL in your browser retrieves an information resource. The URLs are accompanied by a method that specifies how you want to interact with the resource. Common methods include get, which translates as read, post, which translates as create, put, which translates as update, and delete, which translates as remove. The endpoint usually includes query parameters that specify more details about the representation of the resource you want to see. For example, you might specify in a query parameter that you want to limit the display of 5 instances of the resource. Here's what a sample endpoint might look like. http apiserver.com/homes limit equals 5 format equals JSON. The endpoint shows the whole path to the resource. However, in documentation, you usually separate this URL into more specific parts. The base path, or base URL, or host, refers to the common path for the API. In the example above, the base path is http apiserver.com. The endpoint refers to the end path of the endpoint. In the example above, that's /homes. The limit equals 5 format equals JSON part of the endpoint contains query string parameters for the endpoint. In the example above, this endpoint would get the homes resource and limit the result to 5 homes. It would return the response in JSON format. You can have multiple endpoints that refer to the same resource. Here's one variation. http apiserver.com /homes home ID within brackets. The above URL might be an endpoint that retrieves a home resource that contains a particular ID. What is transferred back from the server to the client is the representation of the resource. The resource may have many different representations, showing all homes, homes that match certain criteria, homes in a specific format, and so on. But here we want to see a home with a particular ID. Tip: the relationship between resources and methods is often described in terms of nouns and verbs. The resource is the noun because it is an object or thing. The verb is what you're going to do with that noun. Combining nouns with verbs is how you form the language in REST. We'll explore endpoints in much more depth in the sections to come. For example, in the API reference tutorial, we go through each property in a resource. But I wanted to provide a brief overview here. The web itself follows REST. The terminology of GET request and messages responses transported over HTTP protocol might seem unfamiliar, but this is just the official REST terminology to describe what's happening. Because you've used the web, you're already familiar with how REST APIs work. The web itself essentially follows a RESTful style. If you open a browser and go to I'dRatherBeWriting.com, you're really using HTTP protocol, http:// to submit a GET request to the resource available on a web server. The response from the server sends the content at this resource back to you using HTTP. Your browser is just a client that makes the message response look pretty. And there's a graph showing this, an image showing this. You can see the response in curl if you open a terminal prompt and type curl I'dRatherBeWriting. This assumes you have curl installed. Because the web itself is an example of RESTful style architecture, the way REST APIs work will likely become second nature to you. REST APIs are stateless and cacheable. REST APIs are also stateless and cacheable. Stateless means that each time you access a resource through an endpoint, the API provides the same response. It doesn't remember your last request and take that into account when providing a new response. In other words, there aren't any previously remembered states that the API takes into account with each request. The responses can also be cached to increase the performance. If the browser's cache already contains the information asked for in the request, the browser can just return the information from the cache instead of getting the resource from the server again. Caching with REST APIs is similar to caching of web pages. The browser uses the last modified time value in the HTTP headers to determine if it needs to get the resource again. If the content hasn't been modified since the last time it was retrieved, the cached copy can be used instead. Caching increases the speed of the response. REST APIs have other characteristics which you can dive more deeply into in this REST API tutorial. One of these characteristics includes links in the responses to allow users to page through to additional items. This feature, called HATEOAS, HATEOAS, or hypermedia as the engine of application state. Understanding REST at a higher, more theoretical level isn't my goal here, nor is the knowledge necessary to document a REST API. However, there are many technical books, courses, and websites that explore REST API concepts, constraints, and architecture in more depth that you can consult if you want to. For example, check out Foundations of Programming, Web Services by David Gassner on lynda.com. I'll throw in too, if you don't have lynda.com, you can often access lynda.com for free through your library. Just look up your library site and search if they provide a lynda.com service. REST APIs don't use WSDL files, but some specs exist. An important aspect of REST APIs, especially in the context of documentation, is that they don't use a WSDL file to describe the elements and parameters allowed in the requests and responses. Although there is a possible WADL, Web Application Description Language, file that can be used to describe REST APIs, WADL files are rarely used because they don't adequately describe all the resources, parameters, message formats, and other attributes of the REST API. Remember that the REST API is an architectural style, not a standardized protocol. To understand how to interact with a REST API, you have to read the documentation for the API. The need to read the docs makes the technical writer's role extremely important with REST APIs. Some formal specifications, for example, OpenAPI and RAML, have been developed to describe REST APIs. When you describe your API using OpenAPI or RAML, spelled R-A-M-L, specification, tools that lead When you describe your API using the OpenAPI or RAML specification, tools that can read those specifications, such as Swagger UI or RAML API console, will generate an interactive documentation output. The OpenAPI specification document can take the place of the WSDL file that was more common with SOAP. Tools like Swagger UI that read these specification documents usually produce interactive documentation, featuring API consoles or API explorers, and allow you to try out REST calls and see responses directly in the browser. But don't expect the Swagger UI or RAML API console documentation outputs to include all the details users would need to work with your API. For example, these outputs won't include information about authorization keys, details about workflows and the interdependencies between endpoints, and so on. The Swagger or RAML output usually contains reference documentation only, which typically accounts for only a third or half of the total needed documentation, depending on the API. Overall, REST APIs are more varied and flexible than SOAP APIs, and you almost always need to read the documentation to understand how to interact with the REST API. As you explore REST APIs, you'll find that they differ significantly from one another, especially the format and display of their documentation sites, which we'll look at in a survey of API doc sites. But they all share the common pattern outlined here. At the core of any REST API is a resource and response transmitted over the web. And there's some additional reading here. REST, a FAQ by Diogo Lucas, and Learn REST, a RESTful tutorial by Todd Friedrich. And next activity, identify your goals. Oh, this one's fun. Ramping activity, identify your goals. Ramping up on an API documentation, developing a portfolio of API documentation writing samples, and completing all the activities in this course will require a lot of time and effort. In this activity, you'll identify your goals and reasons for taking the course. Reflecting on your motivation will help you develop the right mindset and stamina to devote the necessary time for the course. Activity. Identify your goals with API documentation. Make sure they align with this course. Think about the following questions. Why are you taking this course? What are your career ambitions related to API documentation? Are you in a place where developer documentation jobs are plentiful? What would you consider to be a successful metric for this course? Do you have the technical mindset needed to excel in the developer documentation fields? For live workshops, we typically share responses in a get-to-know-everyone format, but if you're taking this course online, consider jotting down some thoughts in a journal or blog entry. I can go ahead and share some of mine to help get you thinking, though. So why are you taking this course? Well, I'm in grad school. I'm in a technical writing program, and I entered with the intention of getting into developer documentation, and I knew I'd be working a lot with RESTful API documentation. What are my career ambitions? I would like to work for a software development companies. I want to work on along with a team of developers. Maybe as my skills improve, become a programmer writer, which is just a fancy term for API writer, but with more technical skills, and who can write more types of developer documentation most likely, than just API documentation. Are you in a place where developer documentation jobs are plentiful? I think he covers this later in the course, but it's basically if you're in a big city like San Francisco is amazing, New York, Los Angeles, something like that. They're all great for this specific type of job. What would you consider to be a success metric for this course? Well, for me, that would be a real IRL API doc that I created for some open source software, and I will use this course to help guide me through it, and maybe you too. Do you have the technical mindset needed to excel in the developer documentation fields? Well, I hope so. I've always been kind of a wannabe developer, learning all this the skills and giving up and then coming back to it. But yeah, I think a technical mindset in general is necessary. I like tinkering with appliances, for example, reading guides, figuring out how to fix things. But I really think anyone can learn this. I've interviewed a number of people who write API documentation that never thought they'd work with this sort of thing. It's just a very specific set of skills, tools applied around this frame of thinking, learning how developers think. Whoever you are, I think you can do this. All right, in the next video, we'll go into using an API like a developer and hopefully do some activities. All right, see you in the next video.